Alright, so I wanted to draw this little situation of the cat looking at this flower vase going by. And here's what I wanted to do is I wanted to draw this little gap here, and here's what we're going to say. We're going to say that upwards is positive. And let's just kind of get a couple things here. So we're going to say that x naught is definitely 0. And x is 2 meters, okay? I guess we'll eventually change this to y, but whatever. I just want to get some numbers down. We know that the acceleration, now here's the thing, we're going to say that downward is positive. So we'll say our acceleration is negative 10 meters per second squared, which is fine. And we know that the time going up is 0.25 seconds. Let's be clear though. We don't know V final, and we don't know V initial. So what I'm going to do is I'm going to go ahead and set up some, so V naught is unknown. What I'm going to do is actually set up the equation we need to actually solve this problem. So let's start and just solve what we can solve. So x is 1/2 at squared plus v naught t plus x naught. And just to kind of be clear here, let's just get a little subscript there, a little subscript here, and just kind of keeping this going. I just want to make this look like the AP. There we go. So now, keeping this in mind, let's plug in the numbers that we actually have here and see what we can solve for. So we have V equal, so we have 2 equals 5 times 0.25 squared, right? And then we actually have, oh god, this is so annoying. Okay. Okay, 0.25 times 0.25, because I'm squaring it, plus this typing's just annoying me, plus V naught times t, which is 0.25, plus 0, because our initial position is 0, according to the way we set up the problem. So our only unknown is the speed at which it sails past the beginning of the window, the bottom of the window. So when we actually isolate V naught, let's just kind of be here, we're going to say 2 equals 5 over 4 plus V naught over 4. Again, actually that's 5 over 16, because 0.25 squared is 16, plus V naught over 4. And so we're going to actually multiply through by 16, so we're going to get 32 is 5 plus 4 times V naught. And so this is going to give us 27 equals 4 V naught. And so I'm getting that V naught is actually equal to 27 divided by 4, oh my gosh, this is so frustrating. Okay, so 4 V naught. So V naught equals 27 divided by 4. So 6 times 4 is 24, So 6.75 meters per second is going to be our V naught. So let's just double check that. 6.75 times 4 is 27. Oh my gosh. Okay, so that was just a nightmare with the typing. All right, now let's go how high above the window the flower pot goes. So this is our launching speed into the air. Let's just calculate how high something would go with this launching speed. So if we were to do that, we would end up getting the following setup, where we're going to have V naught, where we have V squared. I'm going to use the following equation, basically. V squared equals V naught squared plus 2a x minus x naught. And so I'm going to end up getting here, when I reach the very top above however high I'm going to go, that v squared is going to be 0 because I stopped for a second. Then I have 6.75 squared as my initial speed squared, plus 2. Now, downward acceleration is negative 10, plus x that I want to solve for. And when I'm done, I'll subtract 2 to make sure I account for the window. Okay. So I'm going to end up getting 6.75 squared divided by 20, and that gives me a distance of 2.27 meters minus the window. Let me make abstract that right. So 2.27 minus 2 meters for the window, and that gives me 0.27 meters above the window. I'm going to just absolutely double check that I have this right. So I have v squared divided by 20, yeah. So 2.28, sorry, minus the 2 meter window distance. So that's giving me 0.28 meters above the window. So that's how I got that answer. All right.